This is your need to know. This is your need to know.
Okay, ready for this? We're talking about sending a probe to an ocean on another world.
Wow.
Not just any world, though. A moon of Jupiter,
Oh,
buried under miles of ice.
oh wow.
Today's deep dive takes us to Europa.
All right.
Europa's hidden ocean might hold the key to, well, one of the biggest questions out there. Is there life beyond Earth?
You know, what's really fascinating to me is this isn't just some, far-off fantasy.
Right.
We have actual missions, like in the works,
Yeah.
missions that could make this a reality, like within our lifetime.
It's wild, and we've got some incredible articles here detailing the upcoming missions. And let me tell you, the technological hurdles are just as mind-blowing as the concept itself.
Absolutely.
So get ready to have your mind blown as we delve into what it would take to explore this alien ocean, what we might find, and why it matters to, you and me right here on Earth.
One thing that always strikes me is the sheer scale of this whole endeavor.
Yeah.
I mean, we're talking about a moon, Europa, that's about the size of our own moon. But instead of a barren, rocky landscape, it's covered in this incredibly smooth, icy shell.
And under that shell, a global ocean, potentially teeming with more water than all of Earth's oceans combined.
That's right.
That's not a typo, folks. More water than our entire planet. And it gets even crazier. This ocean isn't some frozen wasteland. Scientists believe it could be warm, salty, maybe even harboring hydrothermal vents, like spewing out heat and chemicals from Europa's core.
Exactly. And that's where it gets really interesting from a, habitability standpoint. You see, it's not just about finding water.
Right.
It's about understanding whether an environment could actually support life as we know it.
Okay, so let's unpack that. We've got this warm, salty ocean, potentially with hydrothermal vents pumping out energy. Sounds promising, right?
It does.
But hold on, Europa throws some major curveballs when it comes to exploring it.
Oh, absolutely. The challenges are immense.
Like what?
Well, starting with the radiation, Jupiter's magnetic field is like a cosmic superpower.
Yeah.
It bombards Europa with intense radiation that could fry our electronics in an instant.
So it's like sending a probe into a microwave.
Pretty much.
Talk about a bad day for a robot.
Yeah.
But seriously, how do scientists even begin to tackle that?
Well, that's where the brilliance of human ingenuity comes in. They're
Right.
developing probes with super shielded electronics. It's kind of like giving them radiation-proof vests.
Clever. But then there's that ice shell, right?
Right.
We're talking miles thick, potentially shifting and changing because of the gravitational pull of Jupiter. It's like trying to break into a giant cosmic ice palace,
It is.
guarded by a constantly shifting maze. How do we even get through that?
That's where things get really futuristic. Scientists are developing these amazing robots called cryobots,
I've heard of these.
designed to literally melt their way through the ice. Some of them use heat generated by radioactive decay. It's like a self-contained, super efficient furnace.
Okay, that's just cool. I'm picturing a tiny robot slowly melting its way through miles of ice, finally reaching that alien ocean and sending back the first glimpses of this hidden world.
It's an incredible image.
It's like something out of a sci-fi movie.
It really is, and it highlights a critical point. Sending a probe to Europa's ocean is not just about overcoming technological hurdles.
Right.
It's about understanding this delicate balance of this environment.
Right, because it's not enough to just get there, right?
Exactly.
We need to ensure the probe can withstand the crushing pressure of the ocean compared to the vacuum of space,
Absolutely.
communicate back to Earth,
Of course.
and most importantly, not contaminate this pristine environment with, earthly microbes.
Exactly. Imagine the excitement of finding life on Europa, only to realize we brought it there ourselves.
Oh, that would be bad.
That's why planetary protection is a top priority in these missions. But on the flip side, can you imagine the challenges of designing a probe that can withstand that pressure difference?
I can't even imagine.
It's like going from the bottom of the Mariana Trench straight into outer space.
Whoa.
A wild ride for any robot.
Talk about a pressure cooker.
Yeah.
But hey, if we can figure out how to send a human to the moon, I have faith we can crack this too. And it's not like we're starting from scratch, right? We already have missions heading to Jupiter that will, pave the way for a potential Europa ocean probe.
Absolutely. NASA's Europa Clipper mission is set to arrive in the Jovian system in 2030.
Okay.
It's going to perform multiple flybys of Europa to collect data and scout out potential landing sites for a future mission.
So think of it as the advance team, mapping the terrain and sending back intel before we send in the real explorers.
Exactly.
And we can't forget about the European Space Agency's GICE mission,
Right.
launching even sooner, which will also gather crucial data about Europa and other Jovian moons.
It will.
These missions are like laying the groundwork for an epic adventure.
What's truly remarkable is that these missions are happening now, in our lifetime.
That's pretty amazing.
We're on the cusp of unlocking the secrets of a world that could hold the key to understanding the origins of life itself.
It's almost too much to comprehend, right?
Hmm.
But hold on to your hats, folks, because we're just getting started. In the next part of our deep dive, we'll explore the cutting-edge technology being developed to conquer those challenges, from radiation-hardened electronics to self-melting cryobots.
And we'll delve into the even more mind-boggling question about what we might find in that alien ocean, from simple microbes to complex ecosystems, and the profound implications those discoveries would have for humanity. Stay tuned.
This is your need to know. Package electric. Digital. Hacking. Bits. Zeros. Glitch. Cyberspace. Hackathon. Hackathon. Glitch. Cyberspace. Hackathon. Gone. 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 Hackathon. Encrypted. Algorithms. Data. Hack. Screens. Tech. Light. Neon light. Hackathon. Live. Wire. Hacking. Fire. Fire. Tire. This is your need to know.
Welcome back to our deep dive into the mission to explore Europa's ocean. Last time we left off talking about the incredible missions already heading towards Jupiter, like NASA's Europa Clipper and the European Space Agency's JUICE mission.
It's so cool to think about.
It's amazing to think that these spacecraft are out there, like right now, on their way to this potentially life-harboring moon.
Mind-blowing, right?
Yeah.
And while those missions are busy gathering intel and scouting out landing sites,
Yeah.
scientists back on Earth are hard at work developing the technology that could actually take us to Europa's ocean.
Exactly.
So let's dive into the nuts and bolts of how we might actually get a probe through that massive ice shell and into that alien ocean.
Okay, so the first hurdle, as we discussed, is that incredibly harsh radiation environment around Jupiter.
It's a big one.
It's like a cosmic minefield
Right.
of high-energy particles that could fry our electronics in seconds.
Zap. Gone.
So how do we protect a probe from that?
Yeah, how do we do that? It's all about shielding.
Shielding, yeah.
But we're not talking about your average aluminum foil here.
No.
This is next-level protection.
Exactly. Scientists are developing radiation-hardened electronics using materials and designs that can withstand those intense bombardments.
Like a field.
Think of it as a high-tech suit of armor for our robotic explorer.
So it's like giving the probe a superhero shield to deflect those cosmic rays. Pretty cool.
Yeah.
But even with the best shielding, radiation is still a major concern, right?
Absolutely.
That's why the mission trajectory is so important.
Right. Remember how we talked about Europa Clipper performing a series of flybys
Right.
rather than orbiting Europa directly?
Right.
That's partly to minimize the amount of time the spacecraft spends in the most intense radiation zones.
So it's like a strategic game of cosmic dodgeball.
Yeah.
Get in, grab the data, and get out before those high-energy particles can do too much damage.
Exactly.
But let's talk about the kind of real star of the show.
Okay.
Those incredible cryobots.
Yes.
designed to melt their way through Europa's icy shell. It's like something straight out of a sci-fi movie.
It really is, and there are different types of cryobots being developed,
Cool.
each with its own unique approach.
Okay.
Some of them, like NASA's Prime concept,
Yeah.
use the heat generated by radioactive decay.
Okay.
It's kind of like having a tiny nuclear reactor on board,
Whoa.
providing a constant source of heat to melt the ice.
So that's both awesome and slightly terrifying at the same time.
It is pretty amazing.
But safety is a top priority, right?
Of course.
I mean, they're not just going to launch a mini nuclear reactor into space without some serious precautions.
No, of course not.
Okay.
The radioactive material would be carefully contained and shielded to prevent any leakage or contamination.
Right.
But there are other types of cryobots being developed too.
Oh, interesting.
Some that use electric heaters powered by cables connected to a surface lander.
Oh, okay. So it's like plugging in your electric blanket,
Exactly.
but on a cosmic scale.
Exactly.
I like that.
Ah,
Okay, so while each approach has its pros and cons,
of course.
the core concept is the same, right?
Yeah,
Using heat to melt through that massive ice shell.
exactly.
But it's not just about melting ice, right?
It's not.
Scientists are also exploring other methods,
Yeah.
like mechanical drilling, to get through those frozen layers.
Mm-hmm.
Okay, so imagine a robotic drill slowly boring its way through miles of ice.
It's quite the image.
Sounds like a long and tedious process.
It would be a monumental task, that's for sure. And one of the biggest challenges would be managing those ice cuttings.
Oh, right.
You got to make sure they don't clog up the drill or interfere with the probe's progress.
Right, because you don't want your robotic explorer getting stuck in a giant ice slushy.
Exactly.
Okay, but regardless of the method, whether it's melting or drilling,
Right.
getting through that ice shell is only half the battle.
Exactly. Once the probe reaches that ocean,
Right.
it faces a whole new set of challenges.
Let's talk about those challenges. We've already mentioned the immense pressure of Europa's ocean
Right.
compared to the vacuum of space.
Right.
It's like going from a pressure cooker to a vacuum chamber in an instant.
It is a huge pressure difference.
How do you even design a probe to withstand that?
It's a tough engineering problem for sure.
Yeah.
The probe would need to be incredibly strong,
Right.
able to resist that crushing force
Right.
without being crumpled like a tin can.
So we're talking like titanium reinforced super tough materials here.
Exactly.
Wow. But it's not just about strength, is it?
It's not just about strength, it's also about functionality.
Right,
The
that's-
probes, instruments, cameras, all those systems
Uh-huh.
need to be designed to operate flawlessly under those extreme pressure conditions.
So it's like designing a deep-sea submersible, but for an alien ocean on a distant moon.
It is a very specialized type of engineering.
And remember, it's not just the pressure.
You know.
Europa's ocean is likely incredibly cold and salty too,
Yeah,
which adds another layer of complexity to the design.
absolutely. It's a triple whammy of extreme conditions.
Right.
High pressure,
Yeah.
frigid temperatures,
Uh-huh.
and high salinity.
Yeah.
All working against our intrepid robotic explorer.
But that's what makes this mission so exciting, right?
Oh, absolutely.
It's the ultimate test of human ingenuity, pushing the boundaries of what's possible to explore this uncharted world.
Exactly. And the potential rewards are immense.
Right.
Imagine the thrill of receiving the first images from a probe exploring Europa's ocean.
I know.
It would be like opening a window into an alien world, a world that might harbor life as we know it.
Or even more intriguing, life as we don't know it.
Exactly. Exactly.
That's what I think about.
It's mind-boggling, isn't it?
It is.
The thought of encountering life that evolved completely independently of life on Earth, life that might have taken a totally different evolutionary path,
Yeah.
it's both thrilling and a bit unsettling.
It is. And it's not just about the search for life.
Right.
Exploring Europa's ocean could also reveal secrets about the moon's history.
Of course.
Its geology, its internal structure,
Yeah.
how it interacts with Jupiter and the other Jovian moons.
You're hitting all the points here.
It's like piecing together a giant cosmic puzzle, with each new piece of data revealing more about this fascinating and complex system.
I like that analogy.
Okay, so we've talked about the challenges of getting a probe through the ice and into the ocean.
Right.
But let's not forget about the equally daunting task of communicating with a probe that's potentially miles below the ice and millions of miles away from Earth.
That's a big one. Communication is crucial.
Right.
And it's one of the biggest hurdles scientists are working to overcome.
Right.
Imagine discovering something incredible on Europa only to lose contact with the probe and never know what you found.
Talk about a cosmic cliffhanger.
Right.
So how do they plan to keep the lines of communication open?
Well, one solution is to use a relay system,
Okay.
where the probe sends data to a lander on the surface of Europa,
Okay.
and the lander relays the signal back to Earth. But remember, communicating through miles of ice is no easy feat.
It's like trying to send a text message through a concrete wall. So what's the solution there?
Well, scientists are exploring a variety of options, including acoustic signals,
Okay.
which travel much more effectively through water than through ice. So the probe could send acoustic signals to a receiver on the lander,
Okay.
which would then transmit them back to Earth.
So it's like creating an underwater intercom system,
Exactly.
connecting our robotic explorer to mission control.
Exactly. And these communication systems are being designed with redundancy in mind,
Okay.
incorporating multiple backup options in case one fails.
Because on a mission this complex and this important, you don't want to leave anything to chance.
No, absolutely not.
Okay, so we've covered the incredible engineering challenges of getting a probe to Europa's ocean
We have.
and keeping the lines of communication open.
We have.
But the big question remains.
It does.
What are we hoping to find once we get there?
That's the question that drives this entire endeavor, isn't it?
Yeah,
And it's a question that has captivated scientists and the public alike for decades.
for sure. So let's dive into that question in the next part of our deep dive. We'll explore the tantalizing possibility of finding life on Europa, from simple microbial life to complex ecosystems, and the profound implications those discoveries would have for our understanding of the universe and our place within it. Stay tuned.
This is your need to know.
Electric, digital, hacking, bits, zeros, glitch, cyberspace. Hackatron, gone, hacking, bits, zeros, glitch, cyberspace. Hackatron, gone, hacking, zeros, glitch, cyberspace, Electron, gone, hackatron, Electron, encrypted, algorithms, data hack, Electron, screens, tech, lights, neon lights, Electron, hackatron, live, wire, hackatron, fire, tire, electric, digital, hacking, cyberspace, hackatron, gone, hackatron, hacking, bits, zeros, glitch, cyberspace, Electron, gone, hackatron.
This is your need to know.
Welcome back to our deep dive into the mission to explore Europa's ocean. We've talked about the incredible challenges of getting there, the radiation, the ice, the pressure, all that stuff. But we've also touched on the tantalizing possibility that awaits us on this icy moon, the potential for life beyond Earth.
And it's that possibility that really fuels our imagination, isn't it?
It is.
This idea that beneath that icy shell in a world bathed in darkness and like perpetual cold,
Right.
life might have found a way to thrive.
It's amazing.
It is.
It's like something out of a science fiction novel.
I know.
But the science is real.
Mm.
And the possibility is like closer than ever before.
It really is.
We've got missions like the Europa Clipper and JUICE heading towards Jupiter, gathering intel, paving the way for a future mission that could take us to that alien ocean.
And those future missions are where things get really exciting.
Okay, tell me more.
Scientists are already envisioning probes that could go beyond just dipping their toes in the water.
Oh, wow.
They're talking about autonomous underwater vehicles, AUVs, that could roam freely through Europa's ocean, exploring its depths, sending back data for years to come.
Okay, hold on. We're talking about a robotic submarine on another world exploring an alien ocean.
Yeah.
That's like next level stuff.
Yeah.
But seriously, how would that even work?
Well, these AUVs would be incredibly sophisticated machines equipped with cameras, sensors, sampling tools, capable of navigating complex environments and making decisions on their own.
Wow.
Think of them as like robotic explorers charting the unknown depths of Europa's ocean, searching for signs of life, hydrothermal vents, or anything else that might pique their curiosity.
It's like having a fleet of robotic Jacques Cousteaus exploring an alien world.
That's exactly it.
It's amazing. But how would they communicate back to Earth? We're still talking about a probe that's potentially miles below the ice and millions of miles away.
That's a huge challenge, and one that scientists are tackling head-on. One promising approach involves using acoustic signals, which travel much more effectively through water than through ice.
Okay.
The AUV could send those acoustic signals to a receiver on a lander on the surface, and the lander would then relay those signals back to Earth.
Okay, so it's like creating an underwater internet.
Yeah.
Connecting our robotic explorer to mission control back on Earth.
Exactly.
Wow. Okay. But let's get back to the the big question here. What might we actually find in Europa's ocean?
That's the million-dollar question, isn't it? And one that we can only speculate about right now. But the possibilities are truly mind-boggling. We might find simple microbial life, thriving in the darkness around hydrothermal vents, much like we see in Earth's deep oceans. Or we might find something far more complex, perhaps even multicellular organisms, adapted to the unique conditions of Europa's ocean.
And here's where it gets really interesting for me. What if life on Europa evolved completely independently of life on Earth?
It's an incredible thought.
What if it's based on a completely different biochemistry, using different molecules and energy sources? That would be a paradigm shift in our understanding of life itself.
Absolutely. It would force us to rethink everything we know about biology, about the origins of life, and about the potential for life to exist in a wide range of environments throughout the universe.
It's a humbling thought, isn't it?
It is.
To realize that we might be just one small branch on this vast tree of life, a tree that extends far beyond our own planet into the depths of space.
It is. And it's a thought that fills me with a sense of wonder and excitement. Imagine the discoveries that await us, the secrets that Europa's ocean might hold. It's like a treasure chest waiting to be opened.
It really is. And we're standing on the threshold of that discovery
Where?
with the tools and technology to make it happen. It's an incredible time to be alive, to be witnessing this unfolding chapter in human history.
It is. And as we continue to explore Europa and other worlds beyond our own, we're not just expanding our knowledge of the universe, we're expanding our understanding of ourselves, our place in the cosmos, and the infinite possibilities that lie ahead.
Well said. And that brings us to the end of our deep dive into the mission to explore Europa's ocean. We've covered a lot of ground, from the mind-blowing challenges to the incredible potential rewards.
We have.
But one thing is clear. The quest to explore Europa is a testament to the boundless curiosity of the human spirit, our drive to push the limits of what's possible, and our unwavering pursuit of knowledge.
And as we venture further into the unknown, who knows what wonders we'll uncover? Perhaps we'll find that we're not alone in the universe, that life is as common as stars in the night sky, or perhaps we'll find something even more astonishing, something that challenges our very definition of life itself.
The possibilities are endless, and the future is filled with promise. So keep looking up, keep exploring, and keep asking questions. Because out there, among the stars, lies a universe of wonder waiting to be discovered.
This is your need to know.